This is the free web-based resources and tools for teaching chemistry from Dan Damelin and Tom Farmer from the Concord Consortium. Thank you all, by the way, for coming. Tom, would you like to introduce yourself?
Sure. My name is Tom Farmer, and truth be told, I have never taught chemistry. Biology and physics, yes. Middle school, high school, yes. And I've been working as a curriculum developer with the Concord Consortium on a number of projects that we'll talk about today.
And Dan Damelin has worked in the field of education for 27 years as a teacher, curriculum and technology developer, professional development leader, and educational researcher. A long-standing NEACT member, thank you, Dan. He is currently an employee of the nonprofit Concord Consortium, where he has worked on numerous NSF and foundation-funded projects that resulted in open curriculum, open educational resources to support the learning of science through simulation, interactive curriculum, and pedagogy, data analysis, and formative assessment. And I'm really looking forward to this presentation. So I hope that we get to learn a lot today. Thank you, Dan.
Sure, thank you. Thanks for that introduction. I wanted to welcome everybody. I hope the conference has been going well. I've been doing teacher professional development over Zoom for the last 3 weeks, and I'm actually in the middle of one this week. But I had agreed to do this a while back, and excited to share a bunch of resources with you. In this particular session, we're going to sort of look at a survey of some of the kinds of tools and materials that are available by the Concord Consortium. We're a nonprofit research and development organization. Just about everything we do is funded by the National Science Foundation, and everything we make, we give away for free. And during this session, it's short enough that we're trying to give you a survey and a little taste of some of the things. And so you'll have access to all of the materials that we link to and talk about today, as well as contact information for Tom and I, in case you want to follow up and actually go deeper on any of these kinds of tools that we're going to talk about. I'm going to start by sharing my screen and suggesting that you open up, we have a document, a Google Doc here that's basically links to all the things that we're going to show today. And yeah, I think Tom just put it into the chat. Thank you, Tom. And so you can click the link there, and there's also a short link if you want to type it in, short.concord.org/LMM. Can't think of an acronym quickly off the top.
Little Miss Muffet.
Look, Mom, materials I can use. I don't know, something like that. Okay, so the first thing I'm going to start off with, and actually this is how I got involved in Concord years ago. I've been working at the Concord Consortium for 20 years now. And I started out, I taught chemistry for 14 years. And, you know, one of the things that got me into this idea of using technology to help teach chemistry was this, you know, idea that I had all these ideas of how things were going on in this molecular world that the kids couldn't see going on in my head. I've got little videos and ideas and visualizations, and I'm waving my hands around and drawing static things on the board and all that kind of stuff, and trying to figure out how can I open up this black box of the atomic world to help students explore this for themselves. Because I quickly found as a teacher that being able to just describe things and explain things well was not necessarily going to get my students where I needed them to be. They needed to be able to figure stuff out for themselves. They needed to be able to play with that atomic level world in the same way they could play with the macro level world in the hands-on labs that we did. And so the first set of things that I want to introduce you to, we call it the Next Generation Molecular Workbench. And again, you can follow along, or you can just, watch for now. We're going to break up into some, breakout groups to let you play. But I'm going to quickly go through a set of these. So I'm first going to go to this Next Gen Molecular Workbench website, and I'm going to jump down to interactives here, and then browse the interactives. And you can see we have stuff in physics, chemistry, biology, and there's a whole lot of things here for students to be able to explore different aspects of interactions at the atomic level. So we can look at chemical reactions, so potentially looking at concentration and reaction rate, so they can play with adding different amounts of atoms, then seeing how long it takes for, you know, a reaction to complete. I could restart this and add lots of them and say, well, what happens now? So it really gives you a kind of visceral sense of this, you know, concentration, collision theory, reactions going on, allowing students to kind of explore that and see that for themselves. There's lots of stuff around intermolecular attractions. I really like, you know, so some of the, let's see. So this was the one that sort of popped up at the beginning, in which I can play with van der Waals attractions, making them weaker or stronger. I can change the temperature here, and, you know, get to different phase changes. I can even charge them, and we see sort of crystal structures forming where we have ionic interactions. And so this is a kind of thing that we have available that you can have access to. You'll see up here there's a thing that says share. And if you go into share, you have the option of either clicking this link, which will open it into a whole separate window by itself. So you could embed those links in your own materials, the link itself, or if you know how to embed stuff in web pages itself, you can iframe this right into your own web pages or assignments or LMS components if they allow you to embed iframes. So there's a lot of options for different kinds of things that are available for your students to explore, for you to embed in your own materials here. That was one of the locations that you'll find those things. Another place where you'll find resources that are helpful is the STEM Resource Finder. So pretty much all of the simulations and all of our curriculum materials that we develop will end up in the STEM Resource Finder. I'm going to go there. That's learn.concord.org. And I can go here and start searching. I can search for chemistry, although you may want to search for things that are more specific, and you'll find activities, you'll find specific simulations, and Alana, who I saw here, Alana Nelson, you'll be happy to know that we have just finished converting over almost all of the old SAM test things to HTML5. These were very popular materials that we had written years ago in Java, and they've all been converted but not yet released. So all of that stuff will happen soon. We do have collections of materials, and if you start, you may want to scan those to see things that you think that are groupings of materials that are interesting to you. So what I just mentioned to Alana, where if we go down here, you'll see this SAM test grouping, and there's a whole set of materials here: gas laws, intermolecular attractions, spectroscopy. So all of these things are available now in Java if you can run Java, or your students can run Java on their machines. But we're going to put out HTML5 versions of almost all of these pretty soon. So you may want to check back here, or if you haven't already subscribed, I think there's a link at the bottom of these things to, there's not a subscribe down here, but if you go to concord.org, just plain old concord.org, people can subscribe to our newsletter. So about us, and you can subscribe, and we send out an email, not very frequent, won't feel like spam in your email box, pretty infrequent, announcing new materials available. This, when we announce the SAM set of materials, SAM test materials, those will be announced through our e-news there. One of the collections that I wanted to show you in particular that I think would be useful is the interactions curriculum here. And this is one of the collections in the STEM Resource Finder. Now, the interactions curriculum, it was a curriculum that was designed in order to really focus on what a NGSS-aligned curriculum might look like. It was, in fact, the very first curriculum that got this NGSS design badge from Achieve. They, in fact, announced the badge with the awarding of it to the interactions curriculum. So that was, we felt very honored about that. If you scroll down here, you'll see, now this curriculum is actually, it's aimed at what we would call 9th grade physical science or interdisciplinary science. But I would say that there are a lot of pretty high-end chemical concepts within this. The curriculum is called Interactions because it's about interactions and energy at the atomic level, and how seeing the world through that lens can help you bridge across physics, chemistry, biology, and really understand much of what we see around us. In some ways, it's almost like a mini physics first course. These first couple of investigations are about static charge and attractions, but then we dive into, well, what's the source of this electric charge? And we get into atoms and molecules. I'm going to jump to a particular page of a particular activity in here. And you'll see, for example, one of the things that we do, is it this page? Yeah, it's this page. We get into having students explore the idea, there's sort of a history of the atom unit. And one of the things is this idea of the plum pudding model. You can see here, I'll expand this so you can see it bigger, but so you can see, well, if the plum pudding model were true, what would it look like if I shot alpha particles out? We can see some very slight, deviations at the edges. I can turn off the electric field here, so that might be easier to see. But I can also play with, what if I were to concentrate this charge into a much smaller place? Well, now I start to see there's enough mass here and concentrated charge to start to deflect the alpha particles, and very occasionally you'll see one that's reflected back. And this is all embedded. This is all embedded in an activity system in which there are embedded assessments. You can take snapshots and ask them to annotate the model that they were playing with, although we have a little bit of a bug on this thing where the first snapshot I just noticed lately has been just capturing that blue background. Okay, so I could annotate this with the drawing tool here, and you can collect all of this stuff automatically. All of your students' responses come into a dashboard and report. You can, if you're doing video with your classes, you could share some of those responses and have discussion around them. And this is actually an entire semester-long curriculum. I mean, a whole year-long curriculum. But I would say there are pieces of this that are really useful for chemistry, high school chemistry classes. So I would encourage people to explore this particular collection at the STEM Resource Finder. And one thing you'll notice here is there's also a simulations tab. So I've pulled out all the different simulations that are within the curricula, and you have access to just directly playing with those simulations as well, or embedding them into your own materials. So lots of stuff here that I think is useful for high school, even upper level chemistry classes to explore. All right, so this is the molecular dynamics simulations. We have 3 links to where you can find some of that stuff now. What we thought we'd do is we would do a breakout group for, about 10 minutes to give you a chance to explore, and then ask the breakout group leader. And, I figured if we split us into 2 smaller groups, there'd be a little bit more chance for some conversation. So Chris, if you could send us into breakout groups now, and we'll, yeah.
And here we are.
Hello. Sorry if you were waiting.
No worries. Dan, we did have one question about an interactive
Yes.
and whether it still exists.
Okay.
And can someone remind us, it's something like you said steering?
Yeah, it was the one for intermolecular forces, and you had a steering power where you could increase the attraction, and it really showed with the greater the degree of attraction, the amount of energy you would have, or you would have to do to pull a part of a molecule apart.
Yeah.
I love that one.
So yes, that still exists, or a version of that exists. So if we go to intermolecular attractions, and you could say, for example, like comparing dipole-dipole to London dispersion, and let's say that we try pulling apart two nonpolar molecules. So I go, oh, that was pretty easy, versus pulling apart a let's do two polar molecules. So it doesn't have that steering force that you remember before, but it's an analogous thing where you've got this basically a handle to try and pull these things apart, and you get a sense of a much stronger attraction between different kinds of molecules. So there's a couple of those. There's polarity and attractive strength. So there's pairs of molecules. There's factors affecting London dispersion. So you can do things like small molecules or large straight molecules. If you can even do things like this, where it's like you can really emphasize that surface area is important, contact area, and not just that it's a big molecule. And that connects into biology, where you can talk about receptors, and we do have stuff in the bio area that goes more in that direction. So there's a whole bunch of those under the intermolecular attractions here, or in the STEM resource finder. You'll find them if you look there, and on the interactions page. I think we use all of these there too. So you'll find those are multiple places where you'll be able to find those things. All right, another tool that I wanted to introduce to you is a tool that we have for doing data analysis. And I recognize a couple of you from our workshop last year, so this won't be totally new, but I wanted to introduce this to folks because it's a web-based tool for having students explore data. And if you're trying to incorporate students doing labs, or at least even analyzing lab-like data at home, this is another nice tool that I think will support a kind of hybrid or whatever. I mean, we're trying to, since many of us still don't even know what school is going to look like. You can use these tools face-to-face, but they can be in a hybrid model or even a fully remote model, mainly because they're web-based, and then we can imagine how you would do those. So I'm going to start by just doing a demo of the tool, and then we're going to have some time where you get to play around in the tool as well in our breakout rooms. So don't worry if you're not following along, on this first part, because I'm just going to try and demo quickly. So there's a tool that we have called CODAP. It's called the Common Online Data Analysis Platform. A little bit of a mouthful. And I'm actually going to pull up some data from a lab that some students did, in which they were measuring different kinds of soda. And they were, in fact, I'm going to make this a little bigger, so hopefully it's easier to read. I'm going to close these directions for now. And you can see here, this looks like a pretty straightforward, spreadsheet kind of thing, right? And you can, in fact, import any data you want from spreadsheets into here, or type stuff in. This was manually typed in by students. But I want to show you some of the features of this kind of a tool for doing data exploration. First thing is you can see I have a bunch of different measurements from different sodas, and I might want to group this by soda. So I'm going to actually drag this over to the left, and you can see now that I have a hierarchically structured table where I can group things by my regular Coke and my Diet Coke. So this thing itself now starts to get into a different way, because I can start doing calculations at different kinds of groupings, especially when you get into things that have multiple categories by which you might want to group stuff. And I'm gonna, to make a graph, there's no big fancy graph wizard. I just pop out graph. Now I don't have all my data here is just thrown on here. It's not yet configured how I want to view it. And what makes sense probably is something like volume and mass, right? So I would have volume. I get a distribution of my volumes and mass. And you can see here that I've quickly made a graph of all this data. Now I may want to distinguish between the type of soda. So I'm going to drag that right to the middle. And now I'm able to color my points by type of soda. And if I want, notice how I have these categories over here. If I want to be able to turn them on or off quickly, I can say show parent visibility toggles. And now I can toggle some of these different data sets on and off. So I've quickly made a graph of this. If I had a more complex data set, you can imagine trying out different ideas of looking for relationships between what we call these attributes up here of these cases, each row being a case that has various attributes. I can also do, for example, things like formulas. So I'm going to come back over here and I'm going to create a new formula. We'll call this one density. And I'm going to edit the properties so that I can add a unit. In this case, it's going to be grams per milliliter. And maybe I'll change the precision to 3 or 4 here. And I'll apply that. And now I'm going to edit my formula. And the formulas, there's a whole set of functions in here, which you can browse and get those for. And there's all the values that I can add from my table. It also has type ahead. So for example, if I know that I want to do my mass of the soda divided by the volume of the soda, I can do that. And now it's calculated these density values for me. An interesting thing, if I wanted the density values calculated at, well, I'd have to do the, let's see, let's go up here. And I may also want to calculate the mean density of the sodas. And so I could do the same thing here. I'm going to edit the formula. I know there's a mean function of the density. And now I've applied that, and you can see I have my mean densities. Another way, I don't know if anyone has done this with this kind of a density thing, is you could use, I could also get the density from slope, right? Because the slope of these the slope of these of the line through these data will also give me a density, a mass per volume. And so I'm going to turn on just one of these and go over here, and you can see we do have a least squares line regression, which you can turn on, and that will give you a slope. You can also, if you wanted students to do their own kind of curve fitting, you can do that here as well, and get slopes that way. So we could type in values here for whatever we thought that was. I'm not going to type it in now just to save time. One of the things that I thought was interesting when I started looking at this data is when I was looking at the data, it looked to me like everything's pretty good in terms of lining up, in a pretty straight line. So this is pretty good data. And then I decided, well, I'm curious about doing a graph of the densities. So here's my distribution, and I'm going to separate that by type of soda. And now I can look at the distribution of density values I calculated. So for example, I might even want to put on something like the mean onto my graphs here. Now, once I started looking at these, I was like, wow, it looks like these are clustered up here, and I have one down here. Would I consider that an outlier or not? So interesting conversations to start to have about, should I include all of the data that I have? Are some of these things outliers? There are measures like box plots, which can take some measures of outliers, although I don't think I would use a box plot on this small amount of data. But if you had more data, that might be a useful kind of tool to use. But you can see we can add statistical measures here. And if I hover over them, it'll tell me that what the values are. And I can decide, actually, if I think this is an outlier, I can either hide it in my graph. So I can hide the selected case and it will recalculate. Or, let me unhide that. Oops, what just happened there? Sorry, bug. Here, I'll unhide that. If I come over to my data table, I can do things like set aside the selected case, and then it will disappear from all of my data, from all of my graphs. It's set aside, it's not deleted. You could choose to delete it, but we tend to hold data as kind of sacred. So we don't, in case we're really sure it's something bad, you might want to set it aside. So there's all these different kinds of features that you could do here. And of course, you could create your own new table if students were going to type in data. You could create a table with however many columns you want, and you could even set it up with hierarchical structure if you wanted to. All right, so I just went through a lot of stuff really quickly to show you what you can do, but I want to highlight the key things we did. In fact, I'm going to just reload this from the beginning and highlight key things. So key things that we did is you can group stuff to create hierarchies. You can create graphs by clicking the graph button and dragging attributes to the axes. You can drag a third one to the middle if you want to create a legend. And you can do distributional graphs, for example, by dragging the, in this case, it doesn't make sense to do a distribution because I don't have any calculations yet. But if I did a distribution of the volumes that I did, I can do that and then separate them by categories here, the type of soda. So those are the key things for starting to get exploring, and you can add columns and do calculations. So what I'd like to do now is we're going to break back into our breakout groups, and there is a data set that's already in here about periodic table. So you can imagine starting to explore lots of relationships in the periodic table. You can see up here we have lots of properties, and what kinds of graphs could you make here? Well, the simplest one might be something like a graph of atomic number and I don't know, like ionization energy. Now notice it looks sort of like a bunch of dots on here. There is a possibility to do connecting lines. So it starts to look like, periodic trends. And look at this, I'm going to drag over here and select a whole bunch of these bottom ones. And notice every single visualization is linked. So it's showing me where those are appearing in the table. It's showing me what their states are. And if I look in my table here, they are highlighted in the table as well. So all of these are multiply linked visualizations, and you can start playing around. Of course, I can click on something and say, which one is that? Oh, that's krypton. That's argon. Oops, we can zoom into these things, and you can also zoom back out once you click this thing here. So this is just the beginning. We want to let you all play in this system, create graphs, drag and drop some of the attributes in. I'm really curious to see what kinds of charts people make. I spent like 20 minutes earlier myself and discovered new stuff after years of playing around with this data. So I think that you're going to find some interesting things to make here. All right, so I'm going to, we're going to go back into our breakout rooms. You're going to want to make sure you have this open so you can go to the periodic table in CODAP piece. And Tom and I will help with technical issues while you're trying to explore.
I guess we win. Dan will point this out, but there's a number of links under the next section of your agenda that help you get started with CodeApp and working with CodeApp and your students, creating new documents and kind of next steps in general. There's little tutorials and all that kind of stuff that walk you through in a much easier way than this kind of drinking from a fire hose thing that we're doing during the workshop.
Tom, a quick question on the slider. Is that something where you can set values and adjust and it'll filter the data based on that? You tie it in somehow? That's
yeah.
great. Cool.
And it's especially fun, you know, if you have older students or for yourself, to create formulas. It's a little bit like programming and, you know, name something, whatever density, and then have a density slider from one value to another and, you know, change it and see what happens. You know, for example. You probably noticed by now, CodeApp has linear functions, does not have nonlinear functions that you can just plop on. You can create those, you can create custom functions, but typical students would be difficult for them. You're muted, Dan.
There is a way to plot a function on the graph, and then you write the function yourself that you want to plot. So it's not an easy kind of drag and drop for curve fit. Alrighty. Again, I want to reemphasize that this is kind of an introduction to a tool. We have other things that will help you move forward if you want to use that tool or play around with it. And you can also contact us with further questions as you start to explore it. But we think that CodeApp has been a really useful tool. It's very intuitive for making graphs, exploring data sets. If you imagine trying to do the same thing that you were doing with that periodic table data set in Excel or something, you know, going through a graph wizard every time you were trying to make some relationship or whatnot, it really interferes with the kind of questioning, like, oh, I wonder if there's some relationship here, or, you know, seeing the multiple linked visualizations are also kind of key, being able to highlight over some parts and seeing where that shows up in the other graphs. You don't get those kinds of features in your standard spreadsheet. So we think this is a great tool for students. It's web-based, so they can all use it. It's free, and you know, it's really flexible in different ways that you can use it. I am going to quickly demo some other features about importing data in, and it looks like one of these links didn't get over here. So I'm going to put that in on our agenda here. Now I'm going to open CodeApp I'm going to open a brand new CodeApp, and CodeApp itself is, I'm going to share my screen. CodeApp itself is web-based, and again, you can find it at codeapp.concord.org, and you can click Try CodeApp and create a new document. Now, I mentioned before that you can drag and drop data sets in, and so I'm going to go over here, and you can see that I have a comma separated value file here. It's a standard text file format for data. The first row needs to be your headers for the table, and all the other rows in it are the data. Any spreadsheet, Google Sheet, whatever, can export as CSV. So I'm going to click this here. It's a link to a CSV file. It's going to download it, or at least I thought it was going to download it. It must have been a different link that Tom put in here than we had from our other one. Hold on a second. Well, here, I'm going to, let's see if I can download it. from here. Yeah, I can click this download here. So I'm going to download that, and it ends up down here. And I'm going to go to my CodeApp document. Now, if you're using Chrome, which we highly recommend, then you would grab the link. You can just drag this in. But if you used any other browser, then it will just be in your downloads folder, wherever you download stuff to, and you can drag it in to the canvas. And so I now have a file that I can start exploring. So if you had a data set, either a public one that you found online or one that you generated and you want students to use, you could imagine having a Google Sheet, which students are collaboratively filling in data that they're generating, and then you export that as CSV and pull it into here. So those are all ways that you could imagine getting data into CodeApp. Another option for getting data into CodeApp, which I demoed earlier, is of course we can make a new table and just type data in CodeApp, and we can add columns and however many columns we want and set those all up, and people can type data in. Another option is, let's see, there's another option for getting stuff in is using, I don't have that link here. Need to add this stuff. So simulations in CodeApp. And I'm going to put a link to that in just a second. Actually, I'll go there first and then I'll put the link in. And Inquiry Space is another project that does a lot of work with putting, using CodeApp for exploration and data analysis. There's a simulations tab here, and you can see things like, here, let's go down to a chemistry one. We can look at like that concentration and reaction rate one that I mentioned before. So the simulation is now running in CodeApp, and I can add a bunch of atoms, hit start. I'm going to let it go for 15 picoseconds, and then I can hit analyze data, and it will send that data into CodeApp. And so I can look at the time to reach my 80% level of completion. And so I can try that with different concentrations and see how fast that happens, and then create graphs. So that's another way you can do that. Let me get that link for you and put it in our agenda here. So there are simulations that are embedded in CodeApp, which you'll find at this place. You can scroll down and click Simulations tab to see that. And to follow up on CodeApp, to learn more, there's that whole CodeApp website, which I showed briefly. You can see there's stuff here. Let me log out of this. I'm in a mode where, sorry. I'm trying to log out. Go back to CodeApp. All right, so here's where CodeApp.
I was going to say, I think we're in the less is more place. I think doing Sage
all right,
Model.
so, well, I'm worried that we don't have enough time for that. So, but yeah, maybe we'll show a little bit with the Sage Modeler. Okay, so there's 4 educators here. There's getting started with CodeApp tutorials. There's a nice startup guide. So this was kind of throwing you in the deep end to get you a sense of all the stuff it can do. And there's more here for you later. I would follow up with these other links here. All right, there's one last tool, and I'm trying to remember, how late do we go here? We go to
4:45.
4:45. Okay. Well, is it even worth? Yeah. I'm going to skip over this next tool because I don't think I can show it in a reasonable time that we have left. What I would rather do with the time that we have left is actually open up for questions and comments about stuff that you've seen already, and maybe ideas that have sprouted up for people in ways they might incorporate this into either their work, or questions about how to do this stuff remotely or in hybrid mode. Does anybody have any questions or comments or ideas they want to share?
Hi, Dan. I just wanted to say that I'm really looking forward to scaffolding code app in my class. Like I'm going to try to do something really, maybe Diet Coke density at the beginning of the year. I'm really happy you have that data in there because I do that lab and I don't think I can do that lab this year, and I could play around with the data still. And then go and do it in atomic structures and in periodic functions, and then use it again. And I think if I use it a few times during the year, my kids will get really good at it and open it up.
Yeah, I think that you'll find, with this, with CodeApp as a data analysis tool, that students adapt to it pretty quickly, and they're able to make graphs much more fluidly and explore data more kind of intuitively than they can with spreadsheets. So we do recommend that. In terms of thinking about, hybrid and how would you do this kind of thing, or how would you do the scaffolding if you're remote, for example? One of the things that we've had teachers do is do screencasts of themselves, sort of walking through some of the key functions. So in the same way that I demoed something for you, a teacher might make a screencast of themselves working with it to kind of scaffold their students, if that's the kind of thing that they're doing remotely. How about other folks? Are there either simulations that you found interesting or questions you had about how to save and share stuff? Again, this was all very quick. I was trying to show you a bunch of different tools, and we didn't even get to the last one, which I would recommend you take a look at. It'd be fun. Sage Modeler is a system modeling tool, and it allows students to take their conception of how they think some phenomena works, put it on a canvas, and then run it as a simulation, all without having to do programming or writing equations. But that's a workshop for another time. Any other questions or comments about anything you saw today? All right, well, you get to go 5 minutes early then. I won't try and throw another tool at you. I would recommend that you might take a look at Sage Modeler to get a sense of what it can do. And if you have questions or ideas, we're building out units for that now. One of them is going to be an evaporative cooling unit. And there's already one on gas laws that's in there. So you may want to take a look at those. They were, the gas laws one was designed for when we were in class, but the evaporative cooling unit that we're developing now is going to be designed for flexible in-class, hybrid, asynchronous, synchronous kind of use. So you may want to check out Sage Modeler and the curricular units link if you get a chance. Come back there in a month or so, you'll find some more stuff, I believe, that might be useful to you. Thank you all for coming. I really appreciate the time, and have a great rest of your conference.
Thank you, Dan. Thank you, Tom. I posted a link in the side about the daily recap, just 4:45, a few quick minutes. And this session can stay open if anyone wants to stick around and talk about that. There's no reason that you have to get kicked off. Thank you.
Thank you, Chris. Thanks, everyone. I'm happy to stick around.
Yep, me too.
Thanks so much. This was great.
Maybe.
Thanks for coming.
All right. Thank you, Tom. Thank you, Dan. It really was awesome. I actually got a lot out of doing this through Zoom. Like last year, I was in your session about Sage Modeler, and there's something to be said for having it all like right here, multimedia theory, as opposed to like looking up, looking down, looking everywhere in the same room. So I actually think it lent itself really well, these things, to online instruction. Thank you. By the way, Tom, love the t-shirt.
Yeah, we both got our NEAC shirts on.
Oh,
so
you had the, I don't even have that one, Dan.
this one is from 2013.
Oh, I missed that year. Ouch. Ah, you got something I don't. By the way, Dan, Tom, either of you, come to Chem Ed in Waterloo, Ontario next July, if COVID doesn't interfere with it, obviously. But I went to the last two Chem Eds and I'm like, yikes, that's like chemistry Disneyland.
It is. I remember going as a teacher a long, long time ago.
It's going to be awesome. Waterloo's where it started, and so they're going to do it right, I think.
A long drive.
Alana, you should come too. We're going to do a caravan.
That's a long drive. Although I did get my national ID.
Okay.
That in
Great.
itself was a hoot. Did you get yours yet, Chris?
No, I don't think so.
Oh, yeah, I haven't done that either. Well, in Massachusetts, they have you can get one of those, what is it, the real ID or secure
Yeah,
ID?
that's what I meant, the real ID.
Right.
It was a hoot because I'm telling you, our mailbox was blown up with a short round of dynamite, so we shifted all our bills going to our P.O. box. So then you need a copy of your bill as one of your pieces of evidence. I'm like, oh my God, it was awful. It was awful. Then I went there and then they told me, I got some stuff from the town of Exeter showing our place of where we live, as well as the P.O. box and our residence. And they told me we couldn't use it because it had to be a PDF attachment to an email. It has been a nightmare. And my husband's is, I love this one. He needs to show either a social security card or I forget the other document. And so I contact Social Security, and the woman actually told me, you need to send your driver's license in the mail, and another piece of documentation. I'm like, oh God. So I said to her, well, how does he drive without his license? So it's really crazy. Don't wait till the last minute.
Yeah.
So
I'm switching computers, but thank you again, Tom and Dan.
Thanks, Chris.
Alana, I'm not kicking you out, but
I just wanted to talk to.
Oh, did you want to talk to me?
Yeah. I lost 2 of my graphs, just gone. It's like my eye test all over again, Daniel.
Yeah, I remember.
It takes me a while, but I get it eventually.
Yeah. So Tom, Alana, I worked with Alana. Actually, this is toward the end of that, the 2013 year that I've got on here. But I think 2012 might have been. But
I don't know. It was pretty. It was when you started.
Yeah. So Alana was an early technology skeptic when she joined the project.
Oh my God.
And by the end, she was one of our, proselytizers for SAM and RITEST activities.
It doesn't take me much to get to DEFCON 1 when it comes to technology. I just shoot right up to the
But you were an expert by the end.
Well, yeah, but you know how I really understand my students and the frustrational level they get to when they're trying to do something, because that's my limitation, being the age I am. And when I started to integrate technology, my first computer, I was in grad school, for God's sakes, because I couldn't afford one. So I have been trying to do catch up for a long time.
Yeah.
And I know it's a necessary tool, but
especially with the remote. How is it going with you in your teaching this, like the spring, and do you know what's happening in the fall?
I think we're still doing a blend, but that can all change with the governor on the 17th. We're having increases in cases of COVID.
Yeah.
So it's up in the air. No one knows anything. Distance learning was trial by fire.
I can imagine.
Yeah.
It's basically all technology.
Oh yeah. I love gizmos. I love the American Chemical Society simulations, of course, FET Sims.
Yep.
I was doing Khan Academy, and I was also doing Albert.io for my second year kids, because they had to get a test before the end of third quarter. It was a real time sink. I don't think it's going to be any better this year.
Yeah, I think until they have a vaccine, even if they say people are going back based, part-time or full-time, I think it's going to be only a matter of time before everybody's back virtual.
Yeah, and I already, I have a 504 documentation to be able to put in evidence to my HR because of, Dan, where'd you go? There you are. You just shifted side here. I was looking for you on my screen. And I got a wonderful letter from my allergist, and I'm going to go to my GP. And if need be, if my medical condition is exacerbated, being asthma and my allergies, I'm going to pursue going to distance, all digital, and being out of that building. I have to.
Yeah, you gotta protect yourself.
Well, yeah. I mean, the woman told me I could get an air conditioner. I'm like, I don't know how that's going to go because of the movement of air.
Air conditioner.
Yeah.
So we'll make sure none of the air circulates outside of your room. We'll just keep it all there and slow it down.
Well, an air conditioner helps with respiratory issues.
I see.
And then we can get you a lot of plexiglass. That's another one. We can get you a shield. And I said, how's that all going to work with 28 kids in a room? It's just like, because that's the gambit, my honors level first year, 28 kids, most of them will be there. So I don't know. My husband's anxiety is just going up more and more and more. He's ramping up because school's going to be starting soon. And
yeah,
how's it going for you and your children?
Well,
Your family.
My wife and I can both work from home, and so that's been fine. We've been okay financially and all that stuff, but we've been and my daughter has been home. She's kind of going a little stir crazy. But, we've been relaxing things a little bit because it's nice outside, so she can spend time outside with friends. They wear masks, they're socially distant, that kind of thing. And she even had a day camp for 3 weeks where the kids all went and they wore masks the whole time, and nobody got sick. Everything's good. I mean, I'm also fortunate to be in a town. We have 12 cases and haven't had any new cases for like 8 weeks or 7 weeks or something like that. So, the whole town is kind of in our little bubble here.
Urban regions, not good, Dan.
Right. Not at all.
Yeah. So, well, it's good to hear that things are going well. So you have my email sometime this summer, if you get the time. I understand you're extremely busy.
I've been working 24/7 right now. We've been doing PD for the last couple weeks, and also this week. And then I'm on vacation, so it's going to have to be a little later.
Oh, but, yeah. I'm willing to come on board.
If you're interested in using CodeApp and you want a kind of tutorial session on that, then
I don't have any problems with the HTMLs. It's being able to integrate that data component, and the periodic table is a great segue for me.
Yeah. So we can, if you think of a particular use case for how you think you might want to use it, I can work with you to help you figure out how to make that happen. Get you to a place where you feel comfortable. You should go to those getting started, those tutorials that are linked to from the document. So those things are, they're at a much slower pace than what I did today in the workshop. And, just try to what you can do with those, and then we can set up a time to, once you have an idea of what you think you might want to do, we can figure out how to work that and make sure that you feel comfortable with that.
You're the best.
Thanks a lot. One of my favorite, project participants in all time.
I'll be honest, Dan, I have enjoyed your PDs better than anyone else's.
Well, that's-
I can really appreciate your compassion and your sense of humor.
all right, well, thanks. Good luck with the start of the school year. Hopefully
You
it'll
too.
work out.
Don't overdo it. You need rest.
Vacation next week.
Good for you.
Been a long time coming.
Thank you very much.